Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating debugging saga involving a particularly elusive bug, error -22, encountered in embedded software. It's a real whopper of a story.
I'm all ears. What was the initial problem? Sounds like a challenge.
Absolutely. The client, using an NRF 9160 microcontroller with an LTE modem, experienced intermittent failures. The error, NRF error, -22, appeared randomly, triggered by seemingly insignificant code changes. Even changing a line number could cause it. Crazy, right?
Incredible! So the first step was to try and replicate it, I presume?
Exactly. The client had a branch exhibiting the issue, but the randomness made it tough. Initial suspects were a compiler bug or undefined behavior, UB, in the code. Given the use of Rust, UEB seemed less likely. But we still had to check the unsafe blocks and the C code interfacing with the proprietary modem.
Ah, the dreaded unsafe code. Always a fun time. So what about the modem itself? How did that factor in?
The modem is the real mystery here. It's a dual-core chip. One core for user code, the other for the proprietary modem firmware, inaccessible for debugging. Communication happens via a proprietary library, libmodem, a precompiled binary blob. The error, -22, originated from the NRF_send function in this library.
A black box within a black box. So what did the error code actually mean?
That's where things get interesting. The code, NRFEINVAL22, meant invalid argument, but the documentation for NRFSEND didn't list this error. It was an unexpected error, suggesting something was amiss.
Fascinating. So what was the next step in this detective story?
The initial investigation pointed towards a compiler bug, given the sensitivity to compiler versions. We checked newer nightly builds. The bug was present in the 5th of February 2024, but gone in the 6th of February 2024. Too many commits to review, though. So we shifted focus back to the error itself.
Right, a compiler bug would be a nightmare to track down. So what did you find when you looked at the error again?
We delved into the disassembly of libmodem, which, technically, violated Nordic's license. But hey, the debug info was all there. We found that NRFSEND simply called NRFCento, which used shared memory, and IPC for RPC calls. The error handling showed that error code 106, NRF_EFNO support, was being translated to -22.
So the error wasn't actually -22, but a translation of another error? That's some serious sleuthing.
Precisely. The error 106 pointed to an invalid input. We dumped shared memory contents, comparing working and broken versions. The difference? In the broken version, the RPC call had a null pointer and length 0, while the working version had valid values. Mind-boggling.
Unbelievable. So where was the problem? Was it in the buffer handling?
That's what we thought initially. The code looked fine, but adding black box, buffer, before getting the pointer and length fixed the issue. This suggested a compiler optimization gone wrong. The comparison of the binaries with and without black box was a grueling process, though.
Oh dear. So what did you find when you compared the binaries?
The assembly showed extra dereferences in the black box version. We looked at MIR and LLVMIR, but they were virtually the same. Then, the breakthrough. Black box moves the value, not taking a reference. This changed how the closure captured the buffer, adding an extra layer of indirection, explaining the extra dereferences.
Amazing! So it was a compiler optimization issue, but indirectly caused by black_box?
Not exactly. The black box just changed the program behavior enough to avoid the issue. The real culprit? The NRF modem_init function in libmodem was using a pointer to a config struct field that went out of scope, leading to memory corruption. The stack layout was the key.
Incredible! A simple pointer issue causing such havoc. And the solution?
The solution was to make the config struct static, ensuring its lifetime extended beyond the NRF modem_init function. We also opened a ticket with Nordic to improve their documentation. The whole experience highlighted the benefits of Rust's memory safety features. It's a cautionary tale about the pitfalls of C in embedded systems.
A truly remarkable story. Thanks for sharing this thrilling debugging adventure. It's a testament to perseverance and the power of careful analysis.
My pleasure. And remember, listeners, always keep your debugging tools updated. Until next time, goodbye from Tech Bytes and News.
Bye-bye.